Good afternoon. Welcome to a Saturday afternoon in the workshop. The foot piano is nearly finished. I have a lot of footage. It's taken a lot of hours and there's some very interesting and new things for me, so I'm going to divide up what I've got into 3 more videos. This one, where I'm going to show the assembly of the mechanism and the electronics, and then another video on the enclosure, which is a combination of some 3D prints and some fabrication that I've not been able to do before. And then finally I will shoot a final reveal video for people who want to skip the whole build and just see the final result. Hopefully that's okay. If not, you know where the fast forward button is.
Here I have 3 keys printed and wired up to the Teensy 4.0. There's a Hall effect sensor for each key and the keys move a magnet. The Teensy sends the appropriate Midi code to GarageBand on the Mac, which turns that into an instrument note. It took a couple of hours to print and assemble a key mechanism, so I added 2 more over the next few days. And now the piano needs its wooden pedal keys. I'm using white oak and sapele. They're economic, ethical, and I already had some in stock. I'm actually not very good at cutting small, identical bits of wood, so I used pretty much every trick and jig at my disposal. One of the strange things I found is that although I never learned to play the piano, if there's something in front of me that even looks like a piano, my fingers want to play it. I expect a lot of people have that. I forgot to use my high-tech sticky tape to secure the zoom lens, so it slipped during this shot. I'm imagining this instrument will be played with socked feet, so I'm adding some notches for friction. I'm a bit worried about the feet slipping off the smooth pedal keys. I was debating square front versus rounded front for the keys. So whilst I deliberated, I cleaned up the workshop, and then I committed to rounded fronts. One of the benefits of having modelled the entire piece in CAD was that I was pretty confident of the sizing, but it was still very pleasing to see the keys in real life, not just in a computer modelled assembly. In an effort to reduce costs, I based most of the design around M2.5 22mm fixings that I already had a huge bag of. The downside of this was that sometimes I didn't have the clearance for them and needed to shorten them with the bolt croppers. I had planned on just chopping the ends off with a Dremel, but I found that they got too hot and started melting their way out of the plastic. And now a coating of Danish oil on the keys. This is always quite a therapeutic part of the project. You might notice me recycling some of that coat hanger wire from the previous video here. It's just hot glued to some scrap wood to make a drying rack. Lurking in the back of the shot here you can see the keyboard unit, with the curved support rail at the front. This has got three jobs. Firstly, it stops the whole unit rocking forward when you step on a key. Secondly, it helps limit the travel of the natural keys, the longer ones, which come to rest on the top of it. And thirdly, it sandwiches onto the board at each end, where there's the rail support for the rail running through the middle of all the keys. It's made of three parts, each of which is pretty much the maximum size my 3D printer can print. And the curved end parts don't have a particularly good orientation to print in, so I had to add lots of very thin support walls that broke off afterwards. It's not strong enough to function as a carry handle for the unit, but it's strong enough to serve its three main purposes. I'm pretty pleased with these keys in the end. I'm glad I didn't decide to try and 3D print them. Attaching the wooden keys so that they're parallel and the same length was a bit of a concern, so I'm using this jig to mark the screw holes. I don't have a lot of experience yet attaching wood to 3D printed parts, so I wasn't quite sure what the best approach was. So I've gone with both glue and fixings here.
6, 7, 8, 9, 10, 11, 12.
The repetitiveness might be affecting me. Again, in an effort to keep all the keys parallel, I wasn't convinced I could drill a grid of holes neatly enough. So these holes are oversized. These base plates are not structural as such, but they serve as guides for the fixings, to keep them parallel through the larger drilled holes. This will hopefully mean the key units attached to the top side of the board are evenly spaced and parallel. My design uses a single piece of all thread running the length of the instrument through every key and multiple guide blocks. Whilst this adds a lot of rigidity, it means that all of the keys need to be perfectly aligned. It also makes it very tricky to remove just one key for maintenance. There's a bit of a gap in my videos now. The electronics for this project was really pushing me. Then I discovered I'd wired everything up in mirror image. But in some ways, starting again from scratch was actually a bit of a relief. I accepted I didn't have the soldering chops for wiring up an IDC socket, so I took it out of the design and went point to point, making things an awful lot simpler. And this is the first time I got to play this as a musical instrument. Remember how I said I never learned to play the piano? I have to really think about which key is which note. Of course, being Midi, it doesn't have to be a piano, it can be an upright bass. Some more practice required. Thank you for watching.